Okay, welcome. We are going to be talking about covalent bonding in this video. Let's get straight into it. Okay, so covalent bonding, I'm going to explain this with the help of a previous diagram that we know. This is a diagram of an atom of hydrogen, and we know that electrons can fill potential spaces. You've got two potential spaces in the first shell. Remember, these things are called shells. So this is the first energy shell. We've got two available spaces, and in the second energy shell we have 8, and so on. Now with hydrogen, if I had to draw one atom of hydrogen, I know there is one electron available to fill one space. But remember, so effectively this diagram here is filling that space over there. Okay, I'm just going to leave this open for now. So hydrogen's actually a little bit unhappy because it's got this extra space that can be filled, right? So a covalent bond, I'm going to draw another hydrogen over here, except this time I'm going to represent the electron that this atom of hydrogen is filling with an X. Okay, now remember, this one also is unhappy. It's got another available space to fill. So a covalent bond happens when this hydrogen, okay, let's just get rid of these spaces, when this hydrogen moves and joins up with this hydrogen, and these two then will share that electron. So I'm going to draw this a little bit more differently. Because these electrons move, this electron, this one over here, okay, will share that electron, this electron here, with this hydrogen atom, and this one's electron, this hydrogen's electron, will share this electron with this hydrogen atom. Okay, so these two are now sharing a pair of electrons. So this is a, whoopsie, this is a pair of electrons here. We say that this is a pair of electrons. And if you think about it, each of these hydrogen atoms are now quite happy because they've got both of these shells filled. Okay, and when atoms of elements share pairs of electrons, a covalent bond is formed. Okay, let's continue on with understanding this covalent bond, but this time I'm just going to bring myself back into the picture. How's it, everybody? Okay, so let's push on here. So why do covalent bonds form? Well, let's just keep that covalent bond that we've now explained over here in this top left hand corner. So if we had to go and look a little bit more closely at what's going on here, we know that an atom has a nucleus, right? We've got a nucleus, and inside the nucleus are protons and neutrons, right? So that actually makes the nucleus of this atom. If you had to dive in and look at this hydrogen atom's nucleus, it would be positively charged, same as the other one on the other side, right? Positively charged because of those protons. Now if we have a look at these electrons in the middle, okay, we've got this, I'm going to sort of just draw it a little bit bigger here for demonstration reasons. Okay, so we've got these electrons inside. Now these electrons, we know, also have a charge. They are negatively charged. So because of this difference in charge, okay, of the nucleus of the hydrogen atom and the shared pair of electrons, because of this difference in charge, we have this attraction of these two parts of these elements. Okay, so this is what we call a electrostatic force of attraction. And when we talk about attraction, you have to talk about two parts that are being attracted. It's the nucleus of the hydrogen atom, and that's being attracted to the shared pair of electrons, right? So the shared pair of electrons, as I've said, this is negatively charged, and this one is positively charged, and this is what causes the electrostatic force of attraction between these two atoms of hydrogen. And this when we have one pair of shared electrons, this is going to form this bond, this classic line that you see. Okay, and that line represents one pair of shared electrons. If you have more than one pair, then we'll have more than one line, and that's something that I'm going to cover in later videos. So keep an eye out for that. Okay, let's move on here. Okay, so I just want to talk a little bit about energy and atoms being stable. Okay, so let's just give this a nice underlining. There we go. Okay, so when a bond forms, like the one we've talked about, a bond forms, energy is released. Okay, when a bond forms, and in chemistry we talk about things being quite stable when bonds are formed. So we say when a bond forms, it makes, just for now, let's say it makes things more stable. This is not the best way to describe it, but I just want you to keep this in mind when I'm going to talk about my example. So let's have a look now. I'm going to take my headphones off. Hopefully you can still hear me. Just move this camera slightly up. Okay, so let's think about this like this, right? We've got this book. Okay, we'll put that chair over there. Actually, move this chair. Oh yes, we've got this book, right? Now, if I hold the book up like this, it's got a lot of stored energy, right? If I drop the book, you can't quite see that. Book, let me go a little bit further back. If I drop the book like that, it's released all of its energy, right? It had all the stored potential energy. I dropped it, now it's sitting on the floor. All the energy's gone, okay? And it's much more stable. Now this is exactly how a bond is formed. You've got like a hydrogen atom over here, you've got another hydrogen atom over here. They're very unstable, they're very unhappy. They've got one space to fill, okay? They find each other, whoosh, a bond is formed. They're sharing those pair of electrons in the middle here, sharing those pair. Energy has been released, and now these two are much more stable. Okay, so when energy is released in chemistry, we say that things are much more stable. Let's go and have a look at this in our whiteboards. Okay, so let me just get my chair quickly. Okay, so when a bond form makes things more stable. Excellent.